All right, for these last couple lessons here of chapter 13, we're going to be dealing a little more heavily with Venn diagrams. So there's a chart right here. This is on page 371 of your book. I want to point out a couple things in regards to Venn diagrams and link them to some things that we've already done. So a couple symbols that we should be familiar with at this point. The union symbol. Remember, this is most commonly known as set A or set B. So remember, the union of two sets includes everything. You're combining two sets into one large set. So when it comes to a Venn diagram, if this whole area represents set A and this whole area represents set B, when we talk about the union of A or B, we shade all of it because everything is included, becomes one big happy set family right there. So that's where everything got shaded. So this is the diagram that goes with A or B. When we talk about the intersection of A and B, remember we're only talking about the items they have in common. So just this little area of overlap. These are the values that belong to set A and belong to set B, right there in the middle. The complement, remember that goes with the word not. So if I wanted to highlight the area of the things that are not in set A, so again you'll see everything except set A got shaded right there. And so all that green area that you see, this is everything that's not set A. Right here, this is the idea of A only. And so you'll see this notation, but this is really not the common IB notation. I'll show you on the notes here in a second really what that would look like. But this is the area that we would refer to as A only. So these are the things that are in set A that are not a part of set B as well. So if they did have something in common, that would not be included in this A only section. So just like this area right here is B only. So this would be the area that are things that are in B and not set A. And so let me go over to a couple examples here with the notes for the next part of this. All right, so given a Venn diagram right here, so these are some values that have already been identified. So let's identify some areas here using the symbols that we have. So what if I just said, what are the elements that are in set A? Well, look at set A. Right, everything that is in this circle right here is a part of set A. So the elements 1, 2, and 3 are all a part of set A. So 1, 2, and 3. If we did the same thing for the elements in set B, so again, just focus on everything that's in this circle right here for set B. So 3, 4, and 5 are all part of set B. The intersection of A and B. So again, this is just what they have in common. That's that middle portion right there where we have a value of 3. That's set A and B. A or B, remember that's the union of A or B. We want to shade all of it. It becomes one big happy set family for a union. So everything gets to join in here. So 1, 2, 3, 4, and 5. Those are all the items that are either in set A or in set B. So there we go for that. The things that are not in set A. So what are the elements that are not set A? Well, if 1, 2, and 3 are a part of set A, then 4, 5, and 6 are the things that are not in set A. And then there's a lot of variations I could give you along these lines. I'm just trying to give you at least a handful of them to give you an idea of how this works. But what about this one right here? So this says A or B not. So we want to basically, here's A or B. So I want everything but this list. So I want the items that are not a part of set A or B. So 6 right here is the only element that is not a part of set A or set B. And so he's the only one that would fit that description. And like I said, there's many other ways I could give you a notation, but we'll deal with more as time goes on. So here's one where we're going to go the other direction. So now they're going to give you the sets, and we're going to come up with our own Venn diagram right here. So something you always look for to start out with is the universal set. So in this problem, the universal set is natural numbers only. So the things that go into this rectangle can only be natural numbers. So remember, that would include like 0, 1, 2, 3, 4, 5, and so on. So no negatives, no fractions, no decimals. I can only select from natural numbers when I go on to do sets A and B here. So I'm going to have set A and I'm going to have set B. So we'll draw our own sets in there. And they're giving us a description of what are in A and B. So let's start by just identifying what those numbers would be. So multiples of 3 less than 20. So multiples of 3 less than 20 would be things like 3, 6, 9, 12, 15, 18. I got to stop right there because it's got to be less than 20. I can only include natural numbers, so no negatives or anything like that. Set B are prime numbers less than 12. Keep in mind, 1 is not a prime number. 2 is the first prime number. So if I was going to list prime numbers less than 12, it would start with a 2. And then I would have values like 3, 5, 7, and 11 are prime numbers less than 12. So those are the sets for the values for sets A and B. Whenever you're filling out your own diagram, we always want to go inside out. So it's best to start with what they have in common, and then we'll branch out from there. So you can see that they have a 3 in common. And as I go on down the list, it looks like that's the only element that they have in common. So we're going to start there in the middle with a 3, and we'll just branch out from there. So I now want to include all the rest of the values for set A. Right? 3 is already in there. So 6, 9, 12, 15, and 18 are what we call A only. So those are the things that are only in A and not a part of set B. Right here we have 2, 5, 7, and 11. Go into the B only section. Right? And so that's the way we would fill that out. Now, if I look at the universal set, all natural numbers, that's an infinite list. So there's no way to list the specifics into the rest of this rectangle here. So if this were a smaller list, like let's just say it was numbers 1 through 20, well, then any number that I have not yet listed that was a number of 1 through 20, I would then list out here in the rectangle. But since we're dealing with an infinite set of numbers, those cannot be listed, so we're not going to put anything else within that diagram. All right, so a couple things, other things that we're going to be asked to do with Venn diagrams is to shade our own. So, and again, there's a whole lot of variations we could go through on this, but I'm just going to give you a couple so you can see how this works. So right here we have, in the first case, the things that are in set A and not in set B. All right, so what area would that be referring to? So where are the things that are in A and not in B? Well, obviously this whole area, right, is set A. So this is all of set A, but I want the area that is in set A and not in set B. So I do not include this part of it because that's a part of set B. So I only want the things that are in A and not a part of B. So this is what we refer to as the A only section. So the things that are in A and not in B. And so that's the only area that we would shade. So remember, with the intersection, you're only looking for the things that are true about both statements, right? I need to only shade the things that are in A and not in B. So that's the only area that you can shade. Oftentimes people will shade everything outside of B because they say, oh, well, it's not a part of B, so let's shade this area as well. But when you're dealing with an intersection, you can only shade the areas that are true about both statements. It's got to be in set A, and it's got to not be in set B in order for you to shade it. And so that's why we came up with that area right there. Unions are a little different. When you deal with a union, you shade everything. So if it's in set A, I can shade it. If it's in set B, I can shade it. It only has to be true about one of those in order for it to get shaded. Now this particular problem says A or B not. And so obviously if I was going to shade set A or B, right, I would be shading all of this. Right, those are the things that are either in set A or in set B, so I would shade that. But because of the not, This is telling me to shade everything but this. So I need to shade everything except for what I have in blue. So the real answer to this one would be all of this. So this is all the stuff that is not in A or in B. Would all be this stuff right out here. And we'll be getting more practice with shading of Venn diagrams. So go with the red stuff on that. The red stuff is the right answer. The blue is A or B, but we wanted everything that's not A or B, which is the red part. So that's what that should look like. So let me finish off with one reminder here. So when you're dealing with intersections, the key on these is to recognize that you only shade the area that is true about both statements. It's got to be true about him, and it's got to be true about him in order for you to shade it. When you're dealing with a union, it only has to be true about one of them to get shaded. So if it's in here, I can shade it. If it's in here, I can shade it. And then obviously we dealt with a complement in this problem, but that's the key to a union, is it only has to be true about one of them to get shaded. But for the intersection, it's got to be true about both to get shaded.